right, let's look at another example of showing an equivalence relation. So we've got our relation in the set Z. So here we're going to be thinking of Z cross C as our Cartesian product. Defined by our relation is that x minus y is divisible by 3. So even though we've got our Cartesian product, of course it's not every point. We're just looking at the points where x minus y is divisible by 3. So let's start with looking at x related to x. So this is going to imply that x minus x is divisible by 3. Of course, x minus x is equal to 0. 0 is divisible by 3, so that is true. X related to y, well, if x is related to y, it's going to fit our definition. So that's going to imply that x minus y is some multiple of 3. And if we want to be specific, m would be an integer. Well, we want to know if y is related to x is also going to be true. Well, this is going to imply y minus x, but y minus x is just going to be the negative of x minus y, which is going to be a negative 3m. This is also going to be divisible by 3. It'll be negative, but it's still divisible by 3, so therefore we have fit the property of being symmetric. All right, if x is related to y, then that means that x minus y is some multiple of 3. If y is related to z, that's going to mean that y minus z is some other multiple of 3. And now we want to know, is x related to z true? So this is what we're testing. So x related to z is going to imply x minus z. Well, substituting in, we'll leave the x here, and then minus z. Looking over here, I can say that z is going to be the same as y minus 3n. So I've got x minus y minus 3n. Okay. Rearranging, that's going to be x minus y plus 3n. But I know that x minus y is 3m. So I factor out the 3. That is divisible by 3. It fits my definition of relation, so also true. So this is an equivalence relation because we've shown that it's reflexive, symmetric, and transitive. If you're writing this out on a test, you're going to actually want to write the words. We want to say that this is true, therefore it is reflexive. True, therefore reflexive. And that would be enough. We would want to write it for all 3, and then we would want to say, since all 3 are true, it is an equivalence relation.